Thank you very much for this lovely introduction and for this opportunity to talk to you, and of course for plugging the book. So 165 years ago, almost to the day, it's 1850, October 22nd, and this gentleman has an insight. This is Gustav Fechner. He was in Leipzig. And his specific insight that he dates back to this very specific day is the recognition, the realization that properties of the world bear a systematic and lawful relationship to our mental states. And this was the beginning of psychophysics. 11 years later, he wrote a book called The Element of Psychophysics, which is a classic in that field. And then a number of years after that, in 1878, he wrote the first book of empirical aesthetics. It's called A Primer in Empirical Aesthetics. And there are 3 points about him that are relevant to my conversation. The first, as I mentioned, is this insight that our minds are related to the world in a systematic and lawful way, and he went on to identify what has been called Fechner's law. The second is he realized that there was both an outer psychophysics and an inner psychophysics. And what he meant by that was that the outer psychophysics, the properties of the world that are related to our mental states, have to be mediated through our nervous system. And the inner psychophysics is the relationship between what's happening in our nervous system and these lawful relationships between the world and our mind. But he was quite aware of the fact that in 1850, 1860, 1870, we didn't really have the tools to assess inner psychophysics, but he predicted at some point that would happen, and essentially cognitive neuroscience right now is what Fechner thought was the promise of inner psychophysics. And the third point, which I think is relevant here, which he talks about in his book on aesthetics, is he makes a distinction between aesthetics from above and aesthetics from below. And by that, what he means is that up until that point, aesthetics from above were people arguing from first principles, that typically in philosophic aesthetics, that there were first principles by which one would try to define what the aesthetic experience was. And what he thought was important and perhaps, in his view, more fruitful was an aesthetics from below, which meant that this was actually finding out what people thought about aesthetics. And it strikes me that there is a kind of parallel to what you all do, which is rather than simply argue for a design from above, you're interested in the user's experience, and that would, in Fechner's terminology, be a design from below, which is what are people actually experiencing. And he thought aesthetics needed to make this move about 150 years ago. So that's the prelude to the talk. The talk has 5 pieces. These are 5 propositions that I would like to make, and I leave it up to you to decide the extent to which this might apply to design. So the propositions are: beauty matters, responses are automatic, aesthetics engage, values are leaky, and then end with context matters. So when we think about a complex domain where there are various aspects of how to think about it, the outcomes have a lot of factors that go into it. Typically what we do is try to break it down into its component parts, and it's the nature in approaching something scientifically is you pick off pieces of that and try to understand what those relationships are. And what you hope is in doing that, you don't violate the entire process. So if you're looking at component parts, the hope is that these are additive, perhaps even synergistic, and that these have some implications for the entire domain in which you're interested. And so with aesthetic experiences, this is a general framework that Ocean Vartanian and I published not too long ago, which is you can think of the entire domain as having a sensori-motor component, an emotion kind of reward system component, and a semantics, meaning knowledge component. And all of these have different neural bases. There are large-scale neural circuitry that are engaged with this. And our view is that what we call an aesthetic experience emerges out of the interactions of these systems. And so the question is, how do these systems play out, both in the brain and in people's experiences in aesthetic encounters? So, beauty matters. When people think about beauty, typically faces are a prototype kind of object that people think of as beautiful or not beautiful or less than beautiful or very attractive, so on and so forth. But beauty is not confined to faces. We think about places as beautiful. We even think of non-sensory information as beautiful. So mathematical theory can be regarded as beautiful. I'm sure for those of you who code here, you probably think that there are certain kinds of codes that are beautiful, or elegant is often the word that's used in those situations. But the point being that beauty seems to be a kind of attribute that we ascribe to a lot of things. But we start out with faces because faces are prototypic, and we know a fair amount of the psychology of how we process faces and a fair amount of the neuroscience of how we process faces. It turns out that there are probably three aspects to faces that seem to consistently predict when faces are regarded as more attractive. And I will talk about two of them that are relevant here. And the first has to do with symmetry, that in general, if faces are more symmetric, people tend to think of them as more attractive. I should point out that if faces are exactly symmetric, if you took a half a face and mirror reversed it digitally and looked at that, people find that a little bit creepy, right? So I will just want to be clear, it goes to a certain point, but short of that, people prefer faces that are more symmetric than not. And there's an evolutionary story around why that might be. And this seems to occur across cultures. It seems to occur a lot of these attributes of facial beauty. It turns out that infants in the first few months of life will look at faces that adults judge as more beautiful for longer. What's also curious is that infants in the first 3 months of their life are completely race blind. They will look at faces of any ethnicity and still respond in the way that adults tend to respond to what faces are beautiful. Around 6 months, that seems to shift, and in large part, we think that's because of the exposure people have to faces of their own ethnicity. Although in a more diverse culture, presumably that would change. So with symmetry, one commercial aspect of this very early on was by this man, who was Maximilian Faktorowicz, who emigrated to the US, and once he decided to start the cosmetic industry, and he had this beauty micrometer. And for all of you that are branding folk, so this is Max Factor. He changed his name from Maximilian Faktorowicz to Max Factor, which is, talk about a great name for a company. So, but his claim was that there were these subtle asymmetries that one might not even be able to see. And so he had this, I guess you could call this this machine on top of this face of this one, who's Marjorie Reynolds, who's a Hollywood starlet. And the argument was that there were these subtle asymmetries that they would measure. There were over 200 measurements on this thing, and that they could make up, and that's where the term comes from, make up for these minor flaws in order to make someone appear more symmetric by using makeup. So the second facial attribute of relevance also has a historic antecedent. And this is Galton, who some of you may know. He was a polymath. This is at the early or the late part of the 19th century. He was an anthropologist, a statistician, a sociologist. He did a lot of amazing things. But he was also a eugenist. And at the time, he thought that there was a relationship. There could be a relationship between people's facial features and their personalities. And we still have remnants of this notion when you think of someone as having, say, a weak chin or a dominant brow. We still have these remnants of this kind of thinking that tend to be quite prevalent. But he thought if he could take faces of criminals, right, you take all of these faces of criminals and you overlay them and you develop a prototype that one could get what the characteristics of the criminal personality as shown in their faces. And instead of coming up with someone like Jack the Ripper or Moriarty, what he found was that when he did this, that these faces were actually very attractive. And so this is an observation that has since been replicated. And it turns out that this notion of averaging, which is if you take 16 or 32 or 64 faces and you digitally combine them and you get an average of them, that almost always the averaged face is more attractive than any of the individual faces that contributed to this. And the point here that's worth making is that when people talk about whether something like beauty is universal or whether it's highly variable, this is an intermediate example where both apply. So if you take these kinds of experimental observations and say, how does that apply to our lives? What it means is that the faces to which we are exposed to are the source by which we form our own prototypes. And so while the individual faces that we might tend to think as attractive might vary a bit from person to person, the process by which we arrive at those prototypes is universal. It's just a matter of who you're exposed to. Okay. Now, and I'm not going to talk about the third attribute. I think it's not as relevant here. But so what happens in the brain when people look at faces that vary in attractiveness? And these are a couple of studies done in the last decade. And what I would like to emphasize is that parts of the brain, if you look at this image in the top right, towards the top, this area I'm just looking to see if you can see it up there, medial OFC, so orbitofrontal cortex. This is right above where our eyes are. That's why the term orbital. That this seems to be, this is an important area for reward processing. And then there are a variety of other areas, parts of the amygdala that respond to faces, and various other structures that I'm happy to go into detail with. But the point of the slide is that there are specific parts of the brain that are sensitive to rewards that are responsive when we look at faces that we regard as more attractive than others. And the one question that comes up in this world is that is there a common currency? Is there a common currency to reward? So we know, for example, if you like sugar and you tasted some sugar, this part of the brain also is activated. We asked the question a couple of years ago, is our response to attractive places similar to this response to attractive faces? And we looked at interior structures. These are images of interiors. And in this sample, people typically preferred spaces that were more curvilinear than rectilinear. So if there were curves in the space, people typically tended to like it. And what we found again is that in this part of the area, part of the orbitofrontal cortex and part of the medial prefrontal cortex, again, these deep structures in the front of the brain right above the eyes, that there seemed to be, there was increased activity to places that people liked. Again, kind of making this argument for a common currency of rewards. So we then looked at this in a little more carefully, and part of this has to do with new analytic techniques that have been developed over the last few years when people do brain imaging studies. And the basic logic of this is that if you have a same part of the brain that is activated by two different things, you might think, okay, so the response is exactly the same. But there have been recent techniques, analytic techniques, that ask the question of, is the pattern of neural activity in that area the same or not? And it's a kind of machine learning algorithm that looks at the ability for neural activity in that area to classify across different objects. Okay? The analogy I've sometimes used is you can say if you have a house with lights on in several rooms, and what you're doing is you're extracting how much energy that's producing. You can also have a different set of lights on within the same house that produces the same kind of energy. So your activation levels might be the same, but the pattern of activity within the lights might be different. And so these are analytic techniques that try to assess that. So we looked at this with faces and places, and what we found was that, again, in this medial portion of the orbitofrontal cortex, there was no difference both in the level of neural activity and in the pattern analysis, that this part of the brain could not classify whether people were looking at faces or were looking at places, suggesting that it does seem to code for a common currency. But there are other parts more laterally in the orbitofrontal cortex in which there was differentiation, where this part of the brain seemed to be more sensitive to attractive faces and not to places, and the neural activity could be classified by domain. And so the bottom line about this is there are parts of the brain that seem to code for a common currency, that it doesn't matter what the nature of the reward is, that this part of the brain will respond, and there are parts of the brain we think is sensitive to the domain in which one has the experience of something being beautiful. Okay, so responses are automatic, and we think, and there seems to be increasing data to suggest that when we are facing something that is beautiful, even if we are not explicitly thinking about beauty, that we have responses that are analogous to when we are explicitly aware of beauty. So this is a study we did some years ago looking at different faces again, and these were faces that were digitally morphed to be closer or more dissimilar to each other. And in this case, people came in to our lab, to the scanner, in two different sessions. In one session, they were rating the attractiveness of these faces, and in the other, they were making a judgment of identity, which is the one face the same or different than a previous face? So in the identity condition, they're presumably not at least asked to or explicitly thinking about attractiveness, but they are attending to the faces because they're trying to make a judgment of who the person is. And what we find is that in the top left, when people are making these judgments of beauty, that there is a distributed network of the brain that's active, as you might imagine, which includes parts of parts of the frontal cortex, parts of parietal cortex, which typically people think as having to do with attention. But what I'd like to focus is on the occipital cortex. And this is where visual information is processed, and going back to the kind of tripartite model, so this is really asking about the sensory qualities of this. And in occipital cortex, so this is in the back of the brain and the undersurface of the brain, it looks as though, this has been known for a while, that different kinds of categories are processed in slightly different places. So there are parts of the brain that process faces, parts of the brain that processes landscapes, and then objects in general. Visual words are another example. And what we did was we looked at the neural activity in these occipital areas, and what we found was that as faces became more attractive, there was greater neural activity in parts of the brain that processes faces, right? So this is not simply, we think, classifying what the object is. It seems as though there's also an evaluative component within sensory cortices, right? So it suggests that these reward systems, the impact of that reaches quite early into sensory processing. In some ways, the more interesting finding was that when people were making identity judgments, right? So they're not thinking about beauty. This is a week later or a week before, because we counterbalance the order. when we look at this part of their occipital cortex, neural activity continues to respond to how attractive the faces are based on their own judgments offline. Right? So they're not actually thinking about attractiveness, but part of their visual cortex is still reacting. The neural response is still parametrically varied by how attractive the faces are. And so this is what I mean by these. We think that some of these responses to beauty are automatic. And then another group around the same time did this and looked more specifically at some of these reward systems. And they had a similar strategy, but instead of identity, people were making a shape judgment on faces. They were trying to decide which was the wider face. And in that condition, what they find is that in, again, parts of the reward system, specifically orbitofrontal cortex, and a very important structure that's called the Nucleus Accumbens, that seems to be extremely important for rewards, that both these areas seem to respond to faces, to the attractiveness of faces, even when people are making a perceptual judgment, how wide is the face. Okay, so you take both of these findings in combination, and we get the sense that when we are confronted by attractive faces, that both our visual system and the reward system seems to react to and have neural responses to how attractive something is, even when you're explicitly doing something else. And I would suggest what we don't know, but think probably that this is a general phenomenon that generalizes beyond faces. Okay, so aesthetics engages, and there are two ways in which I would like to suggest this engagement happens. The first is, this is a study that was done by Ed Vessel, who's at NYU, and this is a situation where people are looking at a series of paintings. And as you can imagine, people vary quite a bit in terms of what they like. And in some ways, that doesn't matter for their purposes, because they argue that if you code the data, if you analyze the data based on people's individual preferences, what you get is a common experience, even though the trigger for that experience might be quite different, right? So it allows you to not worry about the low-level visual features that might be contributing to the response. And the one thing they do that was different than other studies is people coded, or people responded on a Likert scale from 1 to 4, how much they liked it, but 4 was reserved for those special experiences when you're especially moved by paintings. And what they were interested in is there something qualitatively different about that experience from just, I like it, yeah, that's a little better, that's a little better, to, that one really gets me. And what they found was that there was something qualitatively different about that response. And to explain what that is, I need to go back one step and talk to you about something that in the last 10 or 12 years has gotten a lot of purchase in cognitive neuroscience. It's called the default mode network. And what this is it's a distributed part of the brain. There's parts of medial frontal cortex, parts of parietal cortex. There are about 4 different areas that seem to work in concert. And the critical thing is that these parts of the brain seem to be more active when people are not doing anything. And if you give them a task, that neural activity in this part of the brain actually goes down. And that's why it's called the default mode network. And the idea is that this is when you're daydreaming, when you're imagining things, when you just have that kind of stream of consciousness, that these parts of the brain are active. And they specifically dampen when confronted with the stimulus. And so what Vessel and colleagues find is that in the context of paintings that are especially moving, you get this paradoxical thing, which is the default mode network actually has increased neural activity when it's supposed to not respond to stimuli, right? So it's this odd finding, and one interpretation they have is that in those especially moving experiences, you're thrown back into yourself away from the stimulus. The stimulus is a trigger that throws you back into yourself into kind of a reflective mode. And it's a very interesting finding, and right now in neurosthetics, people are trying to figure out what this actually means in terms of how do we capture this? What are different parts of this network doing? So here's one follow-up study that was done. Instead of using imaging, this is using EEGs. These are brain waves, and the thing about using brain waves is you have much better temporal resolution than you do with fMRI, but poor spatial resolution. And so what they did was they looked at people's responses to images, to paintings that they found especially moving, and they separated this out into two temporal epochs. So one having to do with I think it was, one was between 250 and 750 milliseconds, and the other was between a second and a half. And that there were two different kinds of responses. And this, again, is a topic that's of considerable interest in neurosthetics now, which is what is the temporal sequence of our experiences, that the first instance is not the same as the later instance. And what they found was that the EEG correlate of what might be regarded as a default mode network kicked in later meaning between a second and a half. And so there again, there's an early response and a slightly later response, and that those experiences might be slightly different. There's a different sense of engagement which has to do with our bodies, our bodily engagement, and there are several studies that look at this. This was a study looking at paintings that are either pointillistic or have sort of broad swaths in how the paint was applied. And what the trick was is that people were actually, they're shown these pictures at the top of a kind of grip, and they're primed with their own motor system. So people are shown these pictures, and they actually have to hold a paintbrush, and in this case, they looked specifically at how you would hold a paintbrush if you were going to make a bunch of points. Okay, so this is done. Then they're shown the paintings, and what they find is if people were making this kind of gesture, their preference for pointillistic paintings actually goes up, right? Just doing this kind of motion improves people's or enhances people's preference of these paintings, and it doesn't generalize to the other kind of painting. And this is a kind of a more neuroscience-y version of a similar phenomenon, which is that in the brain, there are certain things that are called mu rhythms. This is, again, an EEG study, and especially over motor cortex. It's a kind of idling rhythm. You can think of your car when it's in park. There's a certain kind of rhythm that it has. You turn it into drive, that changes, right? So mu rhythms are sort of like the idling of your motor system, and when you plan to act, it changes, right? So it can be a marker of, before someone actually acts, of the intention to act. And what they did was they showed these paintings of these, well, I'm not sure I'd even call them paintings, but these artworks of Lucio Fontana, which are these cut canvases. And what they are able to show is when people are looking at these canvases, that their mu rhythms are actually suppressed. And from that, they infer that just looking at these pieces of cut canvases activates people's own motor system before they actually behave. And then we did another a behavioral study that, again, tries to look at how our motor systems are engaged. And this was a simple behavioral study, which is people are shown pairs of faces, and they're making a perceptual judgment. They're making a judgment of whether the face is wider. They have to judge which is the wider face, and it's done with it's a mouse tracking experiment. So you're holding a mouse at the bottom of the screen, and you just move the mouse to whichever face you think is wider. That's the simple experiment. The trick in the experiment is that some of the faces have been separately been normed for being more attractive than others. And these are orthogonalized. So the half of the faces that are wider are more attractive, half of the faces that are wider are less attractive. So attractiveness does not predict the correct response. It's an easy task. People do well on this task. They don't make a lot of errors. But the interesting finding is when the wider face is the lesser attractive face, so the distracting face is the attractive face, that their limbs actually move towards the attractive face before it goes to the target face, which is the wider one, right? So it's as though we're drawn in a very concrete, this is not abstract at all, we are drawn to the attractive face, even though what we're judging is really the opposite face. Okay, so moving on to this notion that values are leaky. And by that I mean, so values came up a number of times yesterday in the talks. When I say values, what I'm talking about are these kind of classic Greek values, of which there were 3 that were emphasized, which is beauty, goodness, and truth. Right? So these were what the Greeks thought were the fundamental human values. And we know from a lot of studies that beauty is conflated with these other values. So for better or worse, that attractive people typically are hired more often. They're given better pay. Children that are attractive are given higher grades unless they're standardized tests. Criminals that are attractive are given lesser punishments. And so these are biases that are built into our systems, and one can argue that we should know about these biases so that you can try to counter them. But nonetheless, they exist. And here are a couple of studies that look at this. So this is a study that again looked at faces that varied in attractiveness, and then people were also given in a separate run were given statements which were supposed to be coded on the morality of the statements. Are these good actions or not good actions? And so here the example given is he rescued the abandoned dog. And people are making these kinds of judgments. And what the investigators find in this case is, again, in parts of this medial orbitofrontal cortex, that for both of these kinds of conditions, you get neural activity in the same area. So this extends this notion of a common currency beyond attractiveness to saying that if you judge something as good and you judge something as beautiful, you end up having very similar neural activity for that. And one can imagine how this might have implications for products as well, which is if they're beautiful, along with that for the ride might come the notion that it is also good. There was a second study that picked up on this, and in this case, instead of using statements, they used pictures. And here there are these pictures of whether you would think this was a good act. Here you have a young child helping a blind person across the street, which presumably most people would think was a good thing to be doing. And also there are faces used. And the other thing they did in this that wasn't done in the earlier study was analogous to when I was talking about responses are automatic, which is that they had a different condition in which people were just judging whether the face, judging the gender of the face, whether the face was a woman or not, and in the little cartoons, whether there was a female character in the cartoon, right? So that's all they're asked to pay attention to, and despite not having the beauty or goodness be part of their explicit judgment, again, in this part of orbitofrontal cortex, they find, in this case a little more lateral than some of the other studies, but they find that there is neural activity to both the good acts and the beautiful faces, even though they're thinking about something else. And again, there is this kind of convergence of neural activity. So this combines this notion that values are leaky and that these responses are automatic. And the final point I'd like to make is that context matters, right? The context in which we see things, we approach things, whether it's cultural, it's our personal histories, all of that has an influence, and there are a couple of studies that speak to this. And at least in the neuroscience of art, we're all stuck with this this urinal, right? Which is, so, when people ask, when artists are asked who was the most influential artist of the 20th century, people don't pick Picasso or Matisse. I mean, those are certainly in the pantheon. But people typically look at this and they say, this is what revolutionized art in the 20th century. Like, there was no longer the kind of interest in beauty, and that context matters. Okay, if someone famous puts a piss pot in a museum, we all stand around in awe and say that this is art. And you've seen versions of this. You can, Jeff Koons' artworks sell for huge amounts of money. So we, as a culture, are actually saying that we value this thing, or at least some people value this enormously. Okay, so what's the implication of this? Is that there are certain kinds of aesthetic experiences that have little to do with the sensory properties of what you are experiencing. And this is where this kind of knowledge meaning plays a huge part. And how do we tap into that experimentally? So this was an experiment that was done with architecture experts and people that were not architecture experts. And people were shown images of different kinds of buildings and also faces. Right? So the idea is that everybody has an opinion about faces. Most people have opinions about buildings. We saw an example in one of the talks yesterday. But not everybody is an expert when it comes to buildings, an expert in the sense of having had formal training in architecture. So what they find is that in this part of the brain that, which I referred to as the Nucleus Accumbens, which we think of as a hedonic hotspot, that this is one that responds quickly to rewards and pleasures of a variety of kinds, that it didn't matter if you were an expert or not, that the reaction to faces was similar to the architects and the non-architects, right? So this seemed to be a kind of common response regardless. But when you looked at this medial orbifrontal cortex, there the activity was modulated in the context of houses, of buildings, by whether someone was an expert, suggesting that in this case, the group of people's own education had an influence on not just in a kind of eggheady cognitive way, but in a way that actually influences people's pleasure response. Right? So these people are getting more pleasure. It's a reverse inference. We are inferring from the part of the brain what the mental state might be. But education in this case actually gives people more pleasure in their response to these faces. And then if you just look at sort of the categorizing, parts of medial temporal cortex, parts of the hippocampus, which we heard some about yesterday, which is very important for memory and learning, that you find that in response to these buildings, that architects have a greater response over there, at least suggesting that they are drawing on their own personal memories and personal education and learning about houses when they're looking at buildings in a way that the non-experts are not. So that's a kind of general response to education. And then there's even a more dramatic one in some ways, and this might be relevant, again, to sort of branding notions and the kind of reputation that, that certain companies might have. So it's conceptually a very simple experiment, which is people are shown abstract images in the scanner, and they're told two things. This was done in Denmark. They're told two things. One is that these abstract images were generated by a computer, that somebody had a clever algorithm and generated these images, and this is what you're looking at, and you kind of judge whether you, the extent to which you like these images. And in the other condition, they're told that these images are hanging in a gallery in Copenhagen, a rather well-known gallery. And so people are, what they're looking at are sort of cutting-edge art, is what people believe in that situation. What they're looking at in both conditions is exactly the same. There is no difference in the sensory information as it's coming in. All that's different is the context in which they're looking at this. And what they find is that when people think what they're looking at is coming from a gallery, that if you ask them to rate the pleasure they derive from these images, that their ratings go up. And again, what we find is that in parts of the brain, again, in this medial orbitofrontal cortex, this area that seems to respond to these sorts of values, there is increased activity in the gallery condition. Again, making by inference, we think that just thinking that this is from a gallery actually enhances people's pleasure experience, even though what they're looking at is exactly the same. And it might be the case that this is where the reputation of a company, the branding of a company may have an analogous kind of reaction, which is that people are not saying they enjoy it because they think they're supposed to. I mean, that might be a part of it, but people's actual enjoyment of the object may be improved based on this kind of contextual piece of information. So that's the end of the talk. Again, the 5 propositions I would like to leave you with, and at least have you think about whether or not this applies to the world of design and people's experiences of design, is I would make a pitch for beauty. Beauty matters. People respond to beauty in an automatic way, even if that's not explicitly what they are engaged in, and that these experiences engage us and engage us physically. They engage our bodies, and that values slop all around. They're leaky, right? You get, if you want someone to think something is good, if they think it's beautiful, they'll probably think it's good. They might even think it's true. And that context matters. It does matter what people bring to the table when they're encountering things, whether this is their cultural, their educational, or their personal experiences. Thank you.
Definitely got time for questions. Who'd like to ask a question?
Which part of the brain was activated additionally when people were looking at faces opposed to rooms?
So when we think of reward systems, there are a set of structures that are commonly activated. And so the important ones are the Nucleus Accumbens, and if you read this literature, sometimes it's referred to as the ventral striatum. So the Nucleus Accumbens is part of the ventral striatum, the orbitofrontal cortex, sometimes the insula, sometimes the medial cingulate. So these are kind of the usual suspects. And one of the questions that that people who work in this are all these things doing the same thing, or are they doing slightly different things? And that's a hot area in neuroeconomics and decision sciences and aesthetics. The immediate response seems to be primarily in the Nucleus Accumbens. I didn't talk about the chemistry of any of this. The Nucleus Accumbens has two major families of neurochemistry. One has to do with dopamine, and most of you hear about dopamine. And the other class that is embedded within that are typically opioid receptors and cannabinoid receptors. And these two things tend to work in concert, but they do something slightly different. In the book that Simon mentioned, I go into this a little bit, because this turns out to be quite interesting, that dopamine seems to be a motivational drug, right? Or drug, or neurochemical. So for example, cocaine plays on the dopamine system. And it drives people to act, and so people think of this as being part of the chemistry of desire. It could be desire for anything, but what dopamine does is drives you to want things. And the actual liking experience, the pure hedonic experience, tends to be mediated primarily through cannabinoid and opiate receptors. And so, if you imagine the kind of, for recreational purposes, the difference in people's reactions to cocaine versus pot or opiates, they're very different responses. And that, I think, captures something about what we think is happening in the brain endogenously under these conditions. But to go back to your original question, the nucleus accumbens is typically that first response, and then the orbifrontal cortex seems to have something to do with the decision that's being made after the response.
Are they part of this default mode network that you were talking about?
They are not part of the default mode network, no.
So actually, that is my question. In the default mode network, is that where creativity is born?
So, yeah, that could be a whole talk. I think the way people think of the default mode network is that it is self-referential, right? You're thinking about yourself, and there's a looseness to it, right? Which is that it's not structured, and that's part of what makes it so interesting. I will, just give you a brief response to the creativity question, which is that generally when people in my world think of creativity, we think of it as in 4 stages, which is the first has to do with just learning the skills, right? If you're going to be creative with music, unless you know how to play your instrument, there's nothing to be creative on, right? So that's a necessary component of being creative, and whatever the domain is, you have to put in the time. And then there is this sort of mysterious piece that we call the incubation period, where you're trying to solve a problem or you're trying to accomplish something, but it's not happening. There's just this kind of fervor that one can sometimes feel before the solution arrives. And then there's the aha moment, right, which is where everything comes together. And then the 4th stage is once you have this personal revelation, you again have to do something with it, which is you have to put it out there in the world so other people can have the benefits of your own creativity. And so those 4 stages, and they're not necessarily linear in the way I've described them. They can loop around and go back and forth, but they seem to be characteristically different. And the periods of incubation in some ways are the most interesting and the most mysterious. And those typically happen for people in low arousal states. Right, so in my own personal experience, it's in the morning before I've had coffee, when I'm standing in the shower, right? I have that warm, fuzzy feeling. That's when the problems I've had at night sort of come together with some kind of solution. So it is possible, we don't know, that this incubation period where there's this sort of inchoate kind of activity, it's not quiescent, but there is some activity, might have something to do with the default mode network.
Thank you.
Yeah.
I was wondering about short-term responses, which are often called reactions, and longer-term responses where you've had a chance to process, think about, and make some decisions on how to respond. But there still seems to me there's still some automatic aspect to that, and I was wondering if you would speak about that.
Yeah, so this is an area that has not been looked at very much, and people are aware, have a sense that this is relatively unexplored area. So when we think of automatic, as I was suggesting, particularly with EEG techniques, one can look at what happens in the first, say, 250, 500, 750 milliseconds. And then the late response is a second to second and a half, right? So, but in the real world, a second, second and a half is not, we wouldn't think of that as a late response. That's still an early response. But the point is, even in that short duration, different things are happening in our response. We don't really have a sense of what happens 5 minutes later, 10 minutes later. We have
3 weeks later.
Right, so we have the extreme version, which is that now you're a graduate student in architecture, right? Or you've had all of these personal experiences. So that's at one end of the sort of temporal dimension. But all of that stuff in between, and it's a bit hard to test experimentally, but so we just don't know.
Yeah, thanks.
Final question? Right, let's put our hands together. That was fabulous.